So hey guys, this is Dipesh, and in this particular video we'll be starting with our machine learning and deep learning playlist. So yeah, let's get started. The just a quick notice that you may not understand some of the terms that I use in this particular video, and it's completely okay because nobody does. Okay, even I didn't understand all this stuff at once. So you don't expect to understand everything at once. There will be a lot of terms that you will not understand just right now, and it's completely okay because until and unless the thing about machine learning is that until and unless you haven't written your own machine learning program in Python or something, you will never understand what how the machine learning works, or how what does some of the this concept even mean. All right, so yeah, don't worry about understanding everything in this particular video. In the coming videos, when you apply this machine learning and write some Python code, it will become crystal clear to you. All right, so yeah, let's get started. So the first thing is, what is the difference between traditional programming and machine learning? Okay, now in order to explain the make you understand this clearly, what I have here is I have an example here. All right, now let's say that you want to predict the credit card user. Okay, now let's say you want to predict if a credit card user will repay his debt or not. All right, and you have data on each credit card user. Let's say you have data on 1,000 credit card users, and you want to basically use that data to create a program that will predict if the which will predict if a particular credit card user will pay his loan or not. All right, now some of the data that we have on the user is his income and his saving. All right, now in traditional programming, what we would have done is we would have used the data as input, and we would have tried to create a conditional program. All right, so the data points that we have is the income and the saving. So the most basic traditional approach that we would have followed is writing the if and else statement. So if income is greater than 150k and saving greater than 250k, then loan repay is equal to yes or no, something like that. But in this particular video, in this particular basically example, we had only two data points about each user. First is his income, and the second one is his saving. Okay, so now which is very easy. We can easily create a conditional statement for these two data points, and we can easily create a prediction. But what if, let's say, we have 1,000 data points about each user, including his name, his age, gender, profession. In previous example situation, we had only two data points: their income, the income of each user, and his saving. But let's say we had like 1,000 data points. Now in this particular situation, it becomes like very difficult or even impossible to create a program like this. So how do you write a program that will make use of this 1,000 data points about each user, and use that data to basically predict an outcome? you know so that is where machine learning comes in. Machine basically, in traditional program, we had a lot of handcrafted rules. We wrote basically a lot of if and else statements. These are all basically very handcrafted rules. So now what we want to do is we want to make the machine learn these rules by himself. Rather than creating the rules by us, by manually typing the rules, we want the machine to learn the rules by itself. you know so in traditional programming, what we did was we had an input, and we wrote a program to generate an output. But in machine learning, since if we try to write the program manually, it becomes very difficult. So in machine learning, what we do is we use the input and the output to learn the program, so we make the machine learn the program. So rather than writing a lot of conditional statements like if and else, will basically make the machine learn the program. So what we'll do is we'll give the machine the data, and we'll say the machine, this is the data and I want you to learn from this data, and whenever I tell you, I want you to predict exactly if a credit card user will repay his loan or not. Okay, so here we are not handcrafting the rules by ours, so yeah, keep this thing in mind. All right. In traditional programming, we have the input and we write a program to predict the output. Whereas in machine learning, we have the data. Basically, we have the input and we have the output, and we make the machine learn a program so that we can use that program to predict the output. Okay. Now, don't worry if you don't understand this. Just bear with me. After 2 or 3 videos, it will be very clear to you. So in order to like explain to you, make you the concept of machine learning more clear, I have another example. Okay, I call this example the dollar rupee example. Now let's say that you wanted to find the currency conversion between US dollar and Indian rupees. So basically what you wanted to do was you want to predict how much is $1 worth in Indian rupees, so how would you even go about with this program? How will you write a program that will learn by itself how much is $1 worth in Indian rupees? So now let's say that you don't know how much is $1 worth in Indian rupees, but you do know that $10 is equal to 730 rupees. All right. Now, how will you use this data to predict another value? How will you use that $10 is equal to 730 rupees, and how will you use this data basically to predict how much is $1 worth? So that is the main problem here. So what we'll do is, now in this situation we know that $10 multiplied by x, now x can be any number. Okay, we know that $10 multiplied by x is equal to 730. All right, now the goal of this problem is to learn this parameter x. Okay, so basically if we know what the value of x is, then we can multiply the same value of x with $1 and we'll get the correct answer. So basically, so we know that $10 is equal to $10 multiplied by x is equal to 730. We can multiply the $1 with the same number, that is x, and we'll get the correct answer. But how will you learn the parameter x? This concept in machine learning is called as training, basically. Okay, so what we are doing is we are making the machine learn a program by itself, learn a parameter by itself. Okay, now this is a very very high level overview of machine learning, but most of the machine learning that you will see in future is basically based on this similar concept. Okay, we have an input, we have an output, and we try to learn certain parameters. In this particular case, we have only one parameter, which is x. Okay, now if we go and look up the parameters for GPT-3, GPT-3 is basically a machine learning system created by OpenAI. OpenAI is basically one of the largest AI companies. All right, so GPT-3 number of parameters, you can see that in GPT-3 there are about 175 billion machine learning parameters. So that is a very very huge. It's basically one of the largest machine learning models on this planet. Okay, but we don't have that many parameters. we have only one parameter, which is x. So yeah, so how will we go about learning x? So the most simple, the simplest way what we can do is, we can go about we can start at 0 and gradually increase the value of x. Okay, so let's start with 1. Okay, let's say x is equal to 1. Now here we'll multiply the input with x. So 10 multiplied by 1 is equal to 10. Now the output that we got was also 10, but we know that the correct output is 730, you know. So then again what we will do is, we'll increase the value of x. Now let's say 10 multiplied by x is equal to 2.5. Now the value that we get is 25, but we know again that the correct value is 730. Okay, so we then again increase the value of x, and we keep on increasing the value until we get the correct output, you know. So after like 31 iterations, what we got is 10 multiplied by 73 is equal to 730, and it is the same value as a original value, you know. $10 is equal to 730, and we got 10 multiplied by 73 multiplied by is 73 is equal to 730. Okay, so 10 multiplied by x is equal to 73 is equal to 730. So after 31 iterations, by gradually increasing the value of x, we learned that $10 multiplied by 73 gives us 730 rupees. This is basically a parameter that we have learned here, you know. Now what we can do is, we can take this parameter and we can multiply it by $1, you know. So $1 multiplied by 73 gives us 73, which is the correct answer for the currency rate, you know. So basically what we did was, we had a data, we used that data to train a model, train the machine to learn the parameters, to basically learn a program and then predict the value, you know. So this whole process is called as training. Okay, let me write here. This whole process is called as training. This whole process is called as training. All right, so yeah, that was it. So basically training means learning parameters. Okay, basically making the machine learn a program for us. Okay, all we did was, we had an input and we had an output, and we made the machine learn the parameter or learn the program. All right, so this is basically the whole machine learning is roughly based on this same idea, no? Okay, so we have an input, we have an output, and we basically train the algorithm to learn those parameters. So yeah, now let's move on to the next topic, artificial intelligence versus machine learning versus deep learning. Now all these terms are pretty very different. So let me first tell you the difference between machine learning and deep learning. So machine learning is basically a superset of deep learning. Okay, that is, deep learning is a subfield of machine learning. All right, now the major difference between machine learning and deep learning is the type of methods, type of algorithms that are used in both of them. Okay, so if we look at machine learning, most of the machine learning algorithms are based on statistics. Okay, pure statistics and math, pure statistical matrix. All right, whereas deep learning, in deep learning the algorithms are basically neural networks. So this is basically the only major difference between them. In deep learning we have neural networks, and in machine learning we have algorithms which are mostly based on statistics and use statistical matrix. All right. And if and that was the only major difference between both of them, the machine learning and deep learning. Basically, the only difference between them is the type of algorithms that are used. Okay. Now machine learning and deep learning, they together basically help us achieve artificial intelligence. Okay, so artificial intelligence is kind of like a superset of both machine learning and deep learning. So there's not a lot of difference, there's not a lot of things to cover here. In simple words, machine learning is a part of artificial intelligence and deep learning is a part of machine learning. So yeah, let's move on to the next topic, which is types of machine learning. Okay, now there are different types of machine learning. The three main types are supervised learning, unsupervised learning, and reinforcement learning. Now, depending on the type of machine learning that you're using, you can solve different kinds of problems. Okay. Now, don't worry if you do not know, don't understand this, or don't get what I'm saying right now. Just bear with me. After a few videos, you will definitely understand this. So, there are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. And using each type of machine learning, we can solve a particular type of problem. Okay, so in supervised learning, we basically solve a regression and classification problem, whereas in unsupervised learning, we solve clustering problems, and in reinforcement learning, basically it's a completely different field, and mostly used in games and stuff. So yeah, now don't worry if you don't understand. After I'll be making videos on each of these problems. So yeah, so keep in mind that each particular type of machine learning solves a particular type of solves a particular set of problems. Like the supervised learning can only solve classification and regression problem, whereas unsupervised learning solves only clustering problem. Okay. Now the next thing is the types of data. Now as you may have seen that there is a lot of role, there is a very important role that the data plays in our machine learning, in training our machine learning algorithm. You know, so so it is very important that you understand what data is, what are the different types of data, what are the structures of data, and stuff like that. Okay, so the main two types of data, okay, the main two types of data are structured data and unstructured data. Okay, now structured data is data which you can write, which you can write in a tabular format basically. Okay, so so it could be your spreadsheet or any data which is in your tabular format. So as you can see on the screen, we have like the first name column, the last name column, a column for the address, city, and age. So basically any data that you can write in a tabular format, you can say that it is a structured data. So CSV files or JSON files or database files from relational databases, etc., etc. All these are structured data. Whereas unstructured data is data which cannot be written in a tabular format. Now this may include images, videos, and audios, etc., etc. All right. Now also, like, most of the time you will be working with with structured data in machine learning, whereas when you step into deep learning, you will be most of the time you will be working with unstructured data. Also keep in mind that machine learning algorithms are not so optimized for unstructured data. Okay, machine learning algorithms are best suited for structured data, whereas deep learning models, the neural networks, are best suited for unstructured data. So there are also different types of neural networks uh, for different types of unstructured data. So for images, there are different types of neural networks, whereas for a text data, there are different kinds of neural networks. Okay, so there are different ways to deal with structured and unstructured data. Okay, so that was it. The next thing is, again, like the main difference between machine learning and deep learning. uh, Deep learning uses statistical methods to train the model and solve problem. uh, no Machine learning uses statistical methods to train the model and solve problem, whereas deep learning trains neural networks to solve most problems. Yeah, we discussed that. The next point is, it is not good at handling unstructured data. Now again, as I told you, that in machine learning, the machine learning algorithms are mainly optimized for structured data, and they are not good at handling unstructured data, whereas deep learning algorithms, the neural networks, are really good at handling unstructured data. Machine learning algorithms are easy to train and implement. Yeah, it is true. And the deep learning algorithms are very hard to train and implement. Then again, it is very true. One thing that you may notice while programming machine learning algorithms and deep learning algorithms is that you cannot train. You can easily train the machine learning algorithms on your regular PC, but it is very difficult to train a deep learning neural network on your regular PC. So in order to train complex deep learning algorithms, what we have many other tools. We have tools like Google Colab and stuff. So don't worry if you don't have any powerful PC or a laptop. We'll be using Google Colab, and it's completely free. We can easily train complex neural networks on them. So the next point is, it is not efficient at scaling when training on large data, whereas deep learning is efficient at scaling when training on large data. Again, it is true, because there is because in deep learning, in machine learning, the number of parameters for regular machine learning algorithms is not very large. The regular machine learning algorithms are very lightweight. Okay, so that's the reason you can easily train them on your local PC. Whereas, as compared to if you compare them with deep learning neural networks, deep learning algorithms, these kinds of the neural networks can contain thousands or even millions of parameters at once. So it becomes very difficult to basically train them on your local laptop. And also, as the data increases, they become since they have so large number of parameters, they can easily learn from this large data. Okay, so yeah, so keep this in mind, that machine learning algorithms are not good if you want to learn a lot of learn things from a large amount of data. Whereas if you have a large amount of data, the neural networks do a very good job in learning the parameters. Okay, now I know that you may be finding it very difficult to understand some of this stuff, but please bear with me, because after 2 or 3 videos, when we actually code a machine learning algorithm, it would be pretty crystal clear to you, because this stuff is not that hard. All these terms like training and optimization and models, it will become very clear to you. Again, now let me give you an overview about the workflow of a machine learning project. Now, the workflow of a machine learning project is, the first thing is, we need data. Okay, Now for any machine learning or deep learning project, what we need is we'll need data, and it would be very good to have as much data as we want, as we need. The next thing would be, once we have the data, now the data may not be clean, like it may contain some null values or missing values, or it may not be in required format. So now the next step is basically data processing. So what we want to do is we want to process the data, so it comes in a format which can be easily used by the machine learning model. Okay. Now do not worry about all these things. In the next video, I will be discussing each of this part, like data collection, data processing, training, and evaluation and deployment. I will be discussing each of this point in brief in our next video. So yeah, so once we have the data, we'll perform data pre-processing, and then we'll use this data to train our model. We'll use our data to train the parameters of our model, and the final thing that we'll do is we will evaluate our data. Okay. Now keep this in mind that once the data is clean, and once the data is prepared, what we do, we one of the main things that we do is we split the data. So what we do is we split the data into train and test set. Okay. Now for example, here, so let's say you have like data on 1,000 credit card user. So what we will do is we'll split some part of the data for training our model, and leave some part of our data to test the model. Basically what we'll do is, once the training is done, we'll evaluate our model on the test data to see how good the model has learned. Okay. So this is the thing. So the reason that we divide this data is that we want to evaluate how the model works on the data that it has never seen before. So so the training data, so let's say out of the 1,000 user, out of the data of the 1,000 credit card user, we use 80% of it for training, and we use 20% of it for testing. Now here what we will do is we'll use that 20%. Okay, we'll use that 20% for testing the data. Now this data is never seen by the model. We train the model using the 80% of our data. Okay, this data is basically seen by the model. The model is trained on it itself, on that data itself, but the model has never seen the testing data. So what we do is once the data is clean, we split the data in train and test, and then we train our model on our testing data, and then we evaluate our model on the test data. Okay, so this was it. And once the evaluation is done, then we can easily deploy our model anywhere. We can create a REST API or use it in other application like a website or an app, etc, etc. Okay, so the entire machine learning project basically has three main components: data processing, model training, and deployment. Okay, and the most important thing is that almost 80% of the time, 80% of time is spent on data processing. Now don't worry if you don't get it right now. I will be discussing this in very depth in our next video. Now 80% of our time is spent on data processing, and it is pretty obvious, because because data is very important. It plays a major role in how our model will be trained. So yeah. Also, it is also one of the hardest part in the entire machine learning flow, because like creating the model is not very hard. We have a lot of tools and we have a lot of libraries at our hands, so creating a model and training the model is not that hard. The hardest part here is processing or cleaning the data as efficiently as possible, because the entire basically the performance of our model greatly depends upon our data. So if our data is basically good, then our training for a model will also be very good, and we'll get a pretty good performance out of it. So whenever you will be creating a machine learning project, most of the time will be spent on data processing. Okay. So also, one thing I forgot to mention, that it is not necessary that one person or one single person does all these things. Now, in large companies, what they do is they have many different people for each particular use case. So for data collection and data cleaning, we often have someone called as data engineer. you know Let me highlight it here. For data collection and data processing, we often have someone called as data engineer. And in order to train the model or perform data analysis and evaluate the model, we have someone called as data scientist. All right. So now data engineer basically collects the data and does data processing, whereas a data scientist basically trains the model and evaluates the model. Right. Now, when it comes to deploying the model in a production, there is someone else called as a machine learning engineer. Okay. So machine learning engineer is basically a mixture of software engineer plus a data scientist. Okay, but the main work that a machine learning engineer does is deploy the trained machine learning model in the production environment. Okay, now once the data scientist develops and trains the model and evaluates the model, what the data scientist does is it submits that model to a machine learning engineer, and now it is the job of that particular machine learning engineer to basically deploy this model so that others can use it. Okay, so these are three main roles that you will find very common uh, 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 in this entire machine learning community. Also, it is not very necessary that not that it is not very necessary that all this I'm sorry, it is also very necessary that you at least know some part of all this, at least have a working knowledge of all these different parts. Okay, so as someone who is working in this industry and and creating machine learning models, you should, if not, you should know how to retrieve data, how to clean data, and also how to basically deploy the machine learning model that you have created. If not an expert, you should have a working knowledge in most of these parts. All right. So the next part is the most used tools in machine learning and deep learning. So the most used tools in machine learning are Python. Some of the programming languages are Python and R, and the most used Python libraries are sklearn, keras, tensorflow, and pytorch. Along with them are Google Colab, Jupyter Notebook, etc. Now let me tell you about each one specifically. So Python and R are like one of the major programming languages used in machine learning and data science. This is mainly because of the syntax, because when you are doing machine learning, it is very efficient. It becomes very efficient to not focus on the syntax itself, syntax of the programming. Basically, the reason Python is so popular in machine learning and data science is basically because of its syntax. It provides a very simple syntax, and also creating machine learning. Also, it provides a lot of machine learning and deep learning libraries. Some of the most used libraries are sklearn, keras, tensorflow, and pytorch. Basically, when it comes to machine learning, and I'm not talking about deep learning but just plain machine learning, you must know, you will always use sklearn, because sklearn provides a simple API to almost most of the machine learning algorithms. Okay, and we will be using the same thing. Okay, we will be using Python, and we will be using the sklearn package to create our machine learning models. But when it comes to deep learning, there is another library called as TensorFlow. Okay, TensorFlow and PyTorch. So TensorFlow and PyTorch are one of the leading Python library or Python packages for deep learning. And Keras is basically just an API on top of TensorFlow. Okay, so whenever you will be creating deep learning algorithms, we will be using Keras rather than using TensorFlow, because Keras provides a very simple API, and it's pretty very easy to use as compared to TensorFlow. Okay, so in this particular series, we will be using a Python's sklearn library for machine learning, and then we'll use the Keras library for deep learning applications. All right, and some other tools that we'll use is Google Colab and Jupyter Notebook. Now, Jupyter Notebook, I will tell you what it is in our next video. It is very simple, not that complex, and pretty much excellent tool. Uh, the other tool is Google Colab. Now, again, as I told you, like training machine learning algorithms is not is very easy on your local PC, because machine learning algorithms are not that complex. But when it comes to deep learning, the neural networks are very complex, and it becomes very hard to train them on your local machine. And it's better if you have a GPU. Now, if you don't have a GPU, what you can do is you can use Google Colab. Google Colab is a free tool on which we can very easily train deep learning applications and models. Okay, so don't worry about that. We will be covering each and everything in this series. The next is basically the prerequisites that you must have. Okay, the prerequisites are basically NumPy, Pandas, and Matplotlib. Now, these three are a very must Python libraries. Now, if you are anyone working in machine learning or deep learning or data science, etc., these three are basically like by default libraries that, like, you cannot work without them. Especially NumPy and Pandas. If you want to learn machine learning and deep learning, it is a very must that you must have a working knowledge about NumPy, Pandas, and Matplotlib. All right, and some of the maths that you will need is differential calculus, statistics, probability, and matrices. Okay, now basically it's a high school maths that you learn. Even if you don't have even if you are not good at maths, it's still okay. I will be creating this video for both like software engineers and the math savvy geeks, basically, who also want the maths for that. So yeah, please bear with this series, because I'll be creating some very in-depth videos on machine learning algorithms for both software developers and and also for people who need some mathematical context that is happening in the background for machine learning algorithm. Okay, so yeah, that was it. and here is the index for the course. Okay, these are all the things that you will be learning in this course. The first is the prerequisites, which I told: Python programming, NumPy, Pandas, and Matplotlib. We in machine learning we will be studying the workflow of ML projects. Then we will be studying some regression problems, classification problems, clustering problems, and ensemble problems. Okay. So by the end of this video, you will have a pretty good intermediate knowledge about machine learning and all. Okay. Now once the machine learning series is completed, we'll start directly with our deep learning series. We'll look at what are neural networks, what are activation functions, what are convolutional neural networks, etc., etc. And after the by the end of the series, we'll basically deploy a machine learning app. So basically what we'll do is we'll create our own machine learning app, and we'll deploy it as a REST API on a cloud server. All right. So yeah, that was it, and I hope you understand everything that I told you up till now. Even if you don't understand, don't worry. I know it may be very confusing, because even when I started learning machine learning, it was very difficult for me to like understand each and every these terms and each and every this concept. So please bear with me. I promise you by the end of this course, you will have a pretty good working understanding about machine learning and deep learning.